How's everybody doing this morning?
Good.
Good.
You feeling any better today?
I'm feeling much better, thank you. It was just
Good.
a one-day thing. Maybe it's because I didn't sleep well the night before, but I'm feeling fine. And my dog is hounding me, so we will go into the forest after this this class today. All right, let's go ahead and get started, everybody. So we're going to finish chapter 2 today. I believe we've done about 80% of it, so we'll finish it today. And I know it's a big chapter, and we're really focusing on the fundamentals of security here. We're not doing any fancy security. We will do that later on. We're just focusing on the fundamentals. And I do want to talk about next week at the end of today's class. So I'm just going to carve a couple of minutes at the end to set expectations for the next week, because we do have 11 chapters in 9 weeks. So we're going to have to cover 2 chapters in 2 weeks. And I'm hoping we will be doing that next week. But let's talk about that at the end. So let's see what we did on Tuesday. So on Tuesday, we talked about securing the Cisco iOS and the configuration file, which basically hides them, and then we can restore them later on in case the system did get hacked and somebody did change one or the other file. So we did this. We recovered the router or a switch password just in case a person sets the password and they leave or they're on vacation and we need to have access to the device. We can reset the password, so we covered that. We did talk about syslog. Packet tracer is quite limited when it comes to SNMP and syslog. And we talked about the importance of logging. I'm not going to do it again, and I'm sure it will come up later on. But logging is super important, and we want to log all important security activities, because after the fact, that's all you have. So when management goes to IT and says, could you guys find out what happened? That's all IT has at this point. And we talked about SNMP, and I said it's been around for a very, very long time. It's available in it's supported pretty much on every platform. The problem is that MIP database, I'm sure you guys remember the structure of the MIP database. It's just not very friendly. There's no other way of saying it. It's just not, here it is actually. It's just not very friendly. To get to a variable down here, you have to go through this messy route before you can get to where you want to go. And I believe that's where we stopped. No, we did talk about NTP. And we said it's really important that we synchronize all the computers to a master clock. And that way, when we have activities that happen on a specific day time, they will happen on a specific day time. And that's where we stopped. Yep, CDP, and this is where we are. Any questions before we dive into today's content? Okay, so who remembers what CDP is? CDP is the Cisco protocol. LLDP is the open protocol. They fundamentally do the same thing. And in this course, because this is a Cisco course, we talk about CDP more than we talk about LLDP, but fundamentally they do exactly the same thing. So who remembers what CDP stands for?
Cisco Discovery Protocol.
And what does it do?
Shares device information to other Cisco devices.
Thank you very much. And what is that a problem? Is that something we should be concerned about?
It could be for security purposes.
Exactly. And this is what this course is, right, everybody? This is a security course. And if you were to enable CDP, then any device can say, hey, buddy, can you give me some information about you? And if CDP is enabled, then you share all kind of information. And if it is an unethical hacker, a cracker, then that is a problem, because they're going to find out a lot of information about this device, information they need to hack into the device. Yes?
I was just going to say that I actually disabled LLDP on my WAN interface on my device. I notice it when I do an Nmap scan.
Yes.
Even though CDP is disabled, it still shows that it's a Cisco device. When I disable that, it doesn't show anything when I do an Nmap scan. So I thought that was
Okay,
relevant.
thank you. Are you guys familiar with Nmap? It's a really cool tool. It's an open tool. Write it down, please, everybody, Nmap, and we will probably use it later on. And it shows you a map of your network. So if
Yeah,
you want to see a map of your network, just run it, and then it will give you a lot of useful information. Go ahead.
I was just gonna say, Mark and Joe had us use it in 284.
Okay,
Is
good.
that the right one? Yeah.
Okay, thank you. Thank you. That's one course I don't teach 284, so I don't know what happens there, but I'm glad he did. Okay, good, everybody. So let's talk about CDP. So let's do the lab. This is what CDP does. Let's just jump into the lab. And this would be lab number 8. And I don't expect you to do these labs along with me. I think I go a little bit fast, but you have access to those labs, and I hope you are doing them on your own, at your own speed. Okay, so it's a fairly short lab. So let me go to R1. In fact, I want to do this. I want to create a brand new router. I'm just going to grab a router out of a box. And I'm going to fast forward, and I'm going to go to this brand new router that I just pulled out of the box, and I'm going to say no, en, and then I'm going to say show CDP. And you can see it's enabled by default. Everybody, that's the problem with many of those protocols, is they're enabled by default. And if you don't want to use it, then you have to disable it. So it's enabled by default, and we'll talk about switch defaults in just a few minutes. So let's go through this exercise. So I disable them, and then we want to enable them and see what happens. So here I'm going to type show CDP, and it's disabled. It's because I disabled it. And you already know it's enabled by default. And then if you want to see the neighbors, well, we're not going to see any neighbors here because it's disabled, but I'm going to go ahead and do it. Show CDP neighbors. And I don't have neighbors because CDP is disabled. So let me go ahead and enable it. And to enable it, you just type CDP run. So const CDP run. And now if I was to type show CDP, it's running. And then I want to do the same thing on R2. And CDP run, and the same thing on R3. CDP run, and I believe it's already running on the switches. So CDP, it's running on the switches. So let's fast forward a little, and let's come back to R1. And now let me do show CDP neighbors, and now these are my neighbors, and I'm going to move this out of the way. Okay, so from R1 point of view, R2 is a neighbor, R3 is a neighbor, switch 1 and switch 2 are all neighbors. And it's telling you these are routers, these are switches, this is the platform, this is the port we're using to connect to it, this is the port they use to connect to us. And then if you really want more, you can do detail. And now it's going to give you a lot more details. And this is why this is a security issue. So if I was to go down R2, this is the IP address. It's C1900. We're using serial 000. This is the version of the iOS operating system. And then down, it's talking about the 2 switches. Okay, because from R1 point of view, I connect R3, and here we are. You can see the switches. Okay. So I can't tell you turn it off or leave it on. It really depends on the environment and how important security is. But for each protocol that is enabled by default, we have to ask ourselves, what value is it adding? And if it's not adding any value, then why turn it on? It's also consuming resources. If I was to simulate packet tracer, and you're going to start seeing some CDP packets going back and forth on a regular basis. In fact, let me show you very quickly. So go into simulate, and let me move this. OSPF, STP, CDP, here we go, everybody. So even if you're not doing anything, you know, the network is busy doing housekeeping, and we have some CDP packets floating around. A, it could be a security issue. B, it's consuming resources. So we do have to ask ourselves, you know, what is the benefit? Back to CBA, you know, what is the cost? What is the benefit? And we make a decision based on that. If it's adding value, then sure. If it's not adding value, then you have to ask yourself, why do I want to leave it enabled? Any questions on CDP?
Does the do you disable it by just doing CDP disable, or is it no CDP run?
Hold on.
How do we turn it off?
Very good. Let's find out. So come over here.
You can disable it globally, or you can disable it per interface. So no CDP run is the global command, and then you can do CDP disable per interface.
Okay, very good. So incomplete, and then we say interface. Well, we don't have any interfaces here, but let me, hold on. Let's see what is it asking for. So, no CDP run. And if I heard Cody correctly, Cody was saying that you can disable it, period, or you can only disable it on certain interfaces.
I think it's no CDP enable on the actual interface. I think that's what it is.
Any questions on CDP? So I want to talk about switches for a while, and I want to talk about DTP. DTP. Do you guys remember DTP? For those of you that are in 153, we were talking about it earlier yesterday. DTP. So what does DTP stand for?
Dynamic trunking.
Exactly. And what does it do? Okay. It negotiates with the other device to see if we want to make this connection a trunk. And a trunk is a connection that carries data for multiple VLANs. And the same thing is true. Okay. It's enabled by default. And it is a security issue. And do we want to leave it enabled? Do we want to turn it off? I can't really tell you what the right answer is. It depends. But it certainly is a security issue. And you have to ask yourself, you know, do I want to leave it enabled by default, or do I want to turn it off? But let me talk about switches for a minute. I want to go back into real time. So if I was to take a switch out of a box, everybody. So this is a brand new switch out of the box. I'm going to fast forward. And I come over here. Okay. EN and show interface FA01 switch, and let me show you. So this port is enabled by default, all ports. So on a router, all ports are disabled by default, and this is why whenever you configure an interface, the very last thing you do is you type no shut, which is to enable it. The opposite is true for switches. All ports are enabled by default. And in an environment where security isn't an issue, that's how you want. So someone can plug a device into a switch port and it's working. But in an environment where security is a serious concern, you have to ask yourself, do I really want to leave all these unused ports on a switch enabled, or do I want to disable them and only enable the ones that have a legitimate device connected to it? So please do remember this. It's not covered in chapter 2, but we cover it in other parts of CCNA. And then if you were to come down here, you can see the negotiation of trunking, everybody, is on. Which means, you know, if another device is saying, hey, buddy, you know, do you want to make this interface a trunk, this switch is going to say, yeah, sure, sounds good to me. Let's go ahead and make that happen. Well, that is a consideration. That is a security consideration because a trunk is carrying data for multiple VLANs. And now you have all these VLAN data going over this trunk. Well, do you know where it's going? What if it's going to a cracker computer? Now they have access to the data that is floating over all these different VLANs. Okay. So again, do you want to leave this trunking enabled or do you want to disable it? So please remember on a switch, all the ports are enabled and you may not want to leave them enabled. You may want to do something like this, conf t interface FA01 through 24. How about range? And then shut. Okay. And I just shut all these interfaces on that switch. And then I only enable the interfaces that I know have a legitimate computer connected to them. And from a security point of view, this is good. Okay. So I'm going to do no shut. Okay. And let me come back here. So let me add a new switch. Stay with me, and I'm going to put it right next to this existing switch right here. And I'm going to connect the two, and this is like to like. So 4, let's remember, 4 to 4. Okay. And you can see it went green right away because they are enabled by default. If either side was disabled, then we wouldn't have a connection. And let's say on this brand new switch, remember this is a cracker switch. I come over here and I configure FA04 as a trunk. And let's see what's going to happen. And I'm going to say interface conf t interface FA04 and switch mode access. No, trunk. Okay. And let's see what happens. And now over here, show interface trunk, and it's showing me FA04 is a trunk carrying data for VLAN 1 through 1005. And let's see what happened in switch 0. And show interface trunk. And you can see it said, yep, you want me to be a trunk port? No problem with me. I'm going to go ahead and forward all VLAN data 1 through 1005 to this switch. Everybody? So it's not covered in chapter 2, but this is really chapter 2 material. And that is a security problem. So just like a CDP, do you want DTP to stay up? So let's do another one. I'm going to add another switch. And I'm going to put it right here. And I'm going to connect it to its neighbor. I'm going to use FA04 again, 04. And they're both enabled by default. But I'm going to come over here and I'm going to disable DTP, which may be the right answer. En conf t switch mode access. What if I select an interface FA04 switch mode access and then switch no negotiate. And now if I was to do show interface FA04 switch, and you can see the negotiate is off. Do you guys see it? So negotiation of trunking is off. And now I'm going to go to switch to this brand new switch, and I'm going to configure FA04 on my end as a trunk. En conf t interface FA04 switch mode trunk. Fast forward a little bit. And you can see on the brand new switch where we configured the trunk, it's green. And on the switch where we said we are not negotiating, it's orange. And if I was to open up free and type show interface trunk, it's saying, yep, I'm a trunk. And if I was to come over here and type show interface FA04, sorry, trunk, and we don't have a trunk. And if I want FA04 to be a trunk, then I just have to do the same thing manually on the other side of the cable. So I can manually say it's a trunk on switch 1 and manually say it's a trunk on switch 2, and now it's a trunk. We're just turning off the negotiation. We don't want DTP to do this for us. So over here, I can go to interface FA04, and I can manually change it to a trunk. Switch mode trunk. Fast forward, and now it's a trunk. Show interface. Does this make sense? Is this something we've covered before? I don't really remember if we've covered this. I mean, yeah, we covered it in 153.
Yeah, I remember us doing all the trunking. I remember you talking about the security implications at the time, but yes. I think because we were more focused on the actual process of enabling and setting up trunk stuff, the security kind of just like, hey, it is the security, but you know, we didn't really talk about it.
Good, and I'm really glad I'm re-talking about it. And this is really should belong to chapter 2. This is very much based on the chapter 2 scope. This fits very nicely into chapter 2 scope. And I wanted to wait until now because we talked about CDP, and it's like, okay, it's not just CDP. There's a bunch of other protocols besides CDP, including DTP, that you have to ask yourself, you know, do I want to leave it running? And I already told you what I know. It depends. It depends. So sometimes, yep, you know, you really do want to leave CDP running, and you really do want to leave DTP running, and other times, no. But please remember, on a switch, all the ports are enabled by default. By default. And you may want to disable them. Disable the ones that aren't being used. And that way, you know, someone isn't just going to, and it's going to generate IT help desk questions, right, everybody, especially if it's a switch that's accessible to people and they plug a computer in it and it doesn't work. And of course, they're expecting it's going to work. And they're going to pick up the phone and call. And then you tell them, no, there's a process to enable this interface. You can't just use it. Questions? Move on. Okay, we move on. So we talked about NTP. Okay, we talked about, yep. Please remember, LLDP is the open protocol, CDP is the Cisco protocol, and you see this a lot, and I know you've seen it a lot already. And Cisco is the 800-pound gorilla, and they have their own protocols. And they're, in many cases, they are similar to the open protocol, but it belongs to Cisco. And the reason why you see this a lot with large companies, Microsoft does the same thing, Google does the same thing, Cisco definitely does the same thing. It's because to make a change to an open protocol is a very lengthy process, lengthy, frustrating process, because you have 150 people that need to meet and talk about it and discuss it and make a decision. And companies, large companies don't want to wait. They want to make a decision on Friday and implement it on Monday. Well, this is not going to happen with an open protocol. You'll be lucky if you can get it implemented the same year you made the decision, much less over the weekend. And this is why you see Cisco protocols and open protocols, Microsoft protocols and open protocols, and oftentimes they're very, very similar. The big difference is the company protocols, they can change rapidly, where the open protocols change very slowly. Okay. Auto secure, I'm gonna show you auto secure, everybody. Please don't use it. I don't think anybody wants to use it, but I'm gonna show it to you anyway. Auto secure. So this is lab number 9. And this is basically a program that's gonna ask you lots of questions. Instead of you telling the router how you wanna configure it, you're relying on this tool to do it for you. And if you've never configured a router before, okay, maybe that's the way you wanna go. But it's just a terrible way because nobody wants to sit. Imagine you have 20 routers. Do you really wanna sit behind 20 routers and answer all these questions, one question at a time? All along, I've said, put your configuration in a text file, copy and paste. And if you have 20 routers, I bet you, 70% of the configurations plus or more are the same. And then you copy, and then you make the few changes, and then that becomes the configuration for router 2, and then you make a copy and you make changes, and that becomes the configuration for router 3, and so on. So nobody wants to sit behind a GUI and answer those questions, one question at a time. So let's see what it looks like. So this is the old lab we've been using in chapter 2. Now it's from privilege mode. And then auto, question mark, secure. And you answer questions. So this is what this tool does. And I really don't want to go through the whole process because we could be sitting here for an hour configuring this router one question at a time. And is this router connected to the internet? Yes. Is it one connection? No, I have 2. And then it says, okay, which interface you're using, and you answer this question, and then it asks you another question, and it asks you another question. And that goes on for a while for each router. And now it's like, okay, you have a configuration for this router, and it's going to ask for an IP address and a subnet mask and so on. Does this make sense to you?
Yeah.
Okay. Would you want to use it, Frank?
Probably not.
Okay. Why not? It's just slow. It's just slow. Or you may want to use it once. You say, okay, I'm going to do this tool once just to learn from it. And then I can copy the configuration, and then I create a master template. We have been talking about master templates for your routers, for your switches, for your ASA devices. And then you say, this is my master, this is my template, and I'm going to make a copy of the template, and I'm going to make the changes I need to make. I'm going to change IP addresses, names, etc., etc., etc. And that is the proper way to go about it. And sitting behind a GUI on each device and answering one question at a time is just not a good use of your time. And if you have 20 routers, you're going to be answering the same questions, 20 times. So if you want to do it once, go for it. It may be an educational experience. And after you do it once, maybe twice, it's like, okay, you're done. You're not going to go back and reuse this tool because it's slow, it's inefficient. And as a system administrator, your time is valuable and you want to be efficient. Move on?
Yep.
Okay. So this is that, auto secure. So what's next? MD5. Do you guys remember MD5? What is MD5?
Hashing algorithm.
And how long is the key? Anybody?
2048.
It's 128.
128.
128. And is it super secure in 2020?
No.
No. Very good. So it's not super secure. It may be secure enough for certain purposes. Everybody? So it's not super secure. I don't think I would want to sign anything with an MD5, but if you are using it just to exchange configuration information between 2 switches, a switch and a router, it may be secure enough. It's not perfect, good enough. So remember this, good enough. So this is a hashing algorithm. It generates 128 bit hashing code or hashing key, and it's no longer considered to be super safe, but it could be good enough. So let's go ahead and open it up and see what we want to use it for. And we're using it to authenticate our neighboring routers. That's what we're using it for. Because we're using OSPF and we're exchanging routing information, and routing information is very, very important. I know you guys know this, and you don't really want a cracker, an ethical hacker say, okay, can you please give me your routing information? I'm a router and I would like you to share your routing information with me. And what we're doing here, and this is what we've done up until this point, and what we're doing now is we're saying, let me authenticate you first. Let me make sure you're a device I can trust. And we're using MD5 for that. And all along we've been saying hashing is often used with integrity, which is very, very true, except in this case, we're using it for authentication. So if you were to look at this physical topology, and we have 3 routers, and we're going to configure the same password on all 3 routers. And now the question is, how do we securely exchange this password? Because we're not going to send the password unencrypted. So what we do is we use MD5 to hash the password on R1. And remember, the same password is configured on R1, R2, and R3. So R1 wants to communicate with R3. R1 will hash the password and send it to R3. R3 will hash their own password, and then they will compare the 2 hash codes to one another. And if they are the same, then it says, aha, R1 is legitimate. If they are different, then nope, R1 is not legitimate. I'm not going to exchange OSPF routing information with it. Does the process make sense? So we're using it to authenticate. And this is not uncommon. This is a fairly common process. In fact, every time you log on to an operating system and you type your password, that's the same exact process that happens. They hash, hopefully the operating system is no longer using MD5, but they hash your password. And when you generated your password, it was hashed and stored as a hash code. And then when you log on, they compare the 2 hash keys, hash codes. And if they're the same, then you're good. If not, then it's gonna give you an error message. So we're doing something similar here across devices. So if we are to take a look, okay, and we're doing it per interface, we're using MD5 for authentication, and the key is CS, the password is CS285. So we're using MD5 to hash CS285, and then we send the hashed code to our neighboring router, and the same password is stored in the configuration of your neighboring router, and then they do the same thing. And if you were to change this password in any of these devices, then they're not going to be able to communicate with their neighbors because the hash code is no longer going to match. And I feel like I'm beginning to repeat myself. So let's copy and paste. So this is R1. And then this is R2. And I'm going to stop with R2. It's the same password, CS285, everybody, CS285. You do it on each interface because each of these routers connect to other routers. Fast forward. And if I was to look at the routing table for R1, R2, if I see remote subnets, then they're communicating and the authentication is working. So do show IP route. And you can see the O for OSPF, and it's working. Well, let's do one more thing. Let's come down to 3 and let's add a 0 to the password. 0, 0. And let's see what happens now. Yep. And it should fail authentication because the hash code for CS285 and the hash code for CS285-0 aren't the same. Paste, fast forward, and did I get any error messages? No, but let me see. Show IP route. No O's, everybody? Okay. So R1 and R2 is saying, we don't trust R3 because the hash code didn't match with what they have configured for a MD5 password. Make sense? Easy enough? How important is securing your routing information?
It's very, because if somebody can get in any way, if it's not secure, then they just have free access to the house.
Here you go. So what crackers, unethical hackers want to do is they want to get the map. They want to get the map. Because if you were to want to do an operation, steal a bank, everybody rob a bank, well, you want a map, an escape map. So you know how to get out of there ASAP. And that's what the crackers want. They want a map. What does the network topology looks like? And if they can get their hands on a network topology and see how all these different routers are configured, etc., I'm not going to say the battle is lost, but that is a big victory. That's an exceptional start. Questions on using a hashing algorithm to protect routing information and to authenticate your neighbors? Okay, I'm gonna assume this is straightforward. So have you guys been reading about hashing and PKI and becoming comfortable with both?
I've been skimming over some of it. I think most of the things I've found were more the high level stuff. I need to look at more of the basic info stuff.
Okay. Okay.
Because some of it just went like right over my head because it got into like actual some code of it. And I was like, that's not what I'm looking for, but it's still.
I agree with you, Frank. That's not what you're looking for. You just want to understand. For me, it's a black box. For me, hashing is a black box. I'm not a cryptographer, neither are you. And the math is quickly, very, very quickly is going to go over my head because there's an awful lot of math involved and it's quickly going to go over my head. And I'm not really interested. But I just want to understand, what does it do? And what is the value? And what are the security implications? So that's what I want to know, but I don't really want to understand, the math involved in all of this stuff. It's way too complicated. It's going to go over my head. But understanding what hashing is and understanding a hash code, the importance of a longer hash code, understanding what PKI is and how it works and how it's being used and how it's being used with HTTPS, SSH, how it's being used with secure email, how it's being used to sign files. That doesn't require any math. That requires no math. And that's what I'm talking about. Make sure you understand that. So 11 is talking about a video on Net Academy. I'm just going to show you what the video includes, but we're not going to watch it. You can watch it in your own, everybody. Here it is, 2611, and it covers the following. Configure an NTP, we did this. Okay, configure an NTP for a master and a client, we did this. Enable OSPF authentication, we just did this with MD5. Encrypt all passwords, we did this. Require minimum length password, we did this. Create user account with secure password, we did this. Log messages, we did this. Packet tracer is limited, but we did what packet tracer allows us to do. Configure SSH, which uses a digital certificate on the router, switch, server side. We did this. Secure the boot images, the iOS operating system, and the configuration file. We did this. Create a secure backup configuration. Yep, that's the secure image is for the iOS. The secure backup configuration is for the config file. We did this. And use auto secure. We did this. So just want to show you we've done all of that. And I'm not saying don't watch it. How long is it? Is it 20 minutes? Okay, it's a bit long. But you can watch it, but we've done all that stuff. And we have labs for each of these, as far as PT can take us. So the next, and RSA and ECC, we talked about this. Do you guys remember this from Tuesday? What did we say about ECC? Anybody remembers?
ECC is way more encrypted for a fraction of the bit size that you're going to get with RSA.
Very good. It's much more efficient. And
Yes.
we said RSA has very, very long keys. And they're very, very long because of that unique relationship between private and a public key. And 1024 is no longer considered secure. 2048 is the bare minimum that is secure. 3072, 4096 are better. But then the problem, what's the problem with longer keys?
They take longer to process and decrypt.
Exactly. They take longer to encrypt. They take longer to decrypt. And if you guys remember, an ECC 256-bit key was equivalent to an RSA 3072. Everybody? 256, 3072. So it gives you the same level of security with a much shorter key. And because of that, we're going to start seeing less. That's my unofficial and unprofessional opinion. We're going to start seeing less RSA keys and more ECC keys because they're more efficient. So our very last lab, 13, is how to download a newer version of the iOS operating system. You're going to be doing this. You're not going to be running the same. It's, I don't know what it is now. It's over 16. So you're not going to be using, you know, the latest and greatest version forever. You want to keep those computers up to date, and you want to upgrade to newer versions of the iOS. And I'm going to show you how to do that. And I'm going to show you how to enable some of the packages that are available on the iOS operating system. Because when you buy iOS, you're just paying for the base operating system. And then if you want to use some of the fancier features, you have to pay for. They're not free. You have to pay for each one. And I'm going to show you how to enable the security package. And we will be using the security package later in this course. I don't think next week, maybe next week, maybe as early as a week from today. We'll see. So let's do that. So without looking at the slides, this is what the slides are saying that you have to keep. And we know this from Windows, from Linux, from the other operating systems we use. We want to stay up to date. Not necessarily go to the newer version the first week it's released, but you want to start putting a plan together to upgrade to the newer version at some point. 13. Okay. A very simple topology. We have a router and we have a TFTP, a trivial FTP server. So on R1, show run. We've done this a million times. And at the very top, it's showing you the version of the iOS operating system. We're using 15.1. Let's remember this because we want to upgrade to a newer version in this lab. And then if I was to do show version, let me make this a little bigger. Okay. And here you're going to see two different versions. You're going to see a version for the iOS operating system, and it better be the same one we were looking at before, 15.1. And you're going to see one for ROM-mon, you know, that mini operating system that we used on Tuesday. And then if I was to go to the very end, you can see the packages I was talking about. So the IP base is the base, just like the package is called, and it's enabled. And if I want to use security, and this is a security course, and we're going to be using this package later on, well, you're going to have to enable it. Not only do you have to enable it, you have to pay for it. So nothing is a freebie. You have to pay for that stuff. So you're going to have to go and get a license for these security packages, and then you will be able to enable them on your production environment. And then the same thing is true for the data package. We're not currently using it. We're only using the base package. And if you have a need for the data, then you have to purchase a license or licenses, and then you would be able to upgrade. So we're going to do two things in this lab. We're going to upgrade the operating system, and we're going to enable the security package. And we won't be doing anything with the security package today, but we will maybe starting a week from today. So let's see. And then if we are to go to the TFTP server and go to services and go to TFTP, these are all the files that are available. And you can see we do have a newer version of the iOS operating system at 15.3. And that's the one that we want to use. So we want to upgrade from 15.1 to 15.3. So let's go over the process. Note iOS and Bootstrap, this is the ROM-mon versions, are different. And we all know ROM-mon is the minimal iOS operating system. And let's see what do we have on the R1 flash. And R1 flash being the persistent permanent storage, show flash. And this is our iOS file. So this is what we load into RAM when we boot up this router. And we will talk about those files later on. These are signature definitions, signature files. And I know you all know what a signature file from malware, and we keep it up to date, or the anti-malware software keeps it up to date for you. And here, you know, we're more focused on IPS, IDS, and I believe we have a whole chapter on that later on. So we'll wait until we get there. But right now we're interested in the iOS operating system file. Okay, so let's go ahead and copy the new file. So I am going to, so I'm going to copy to TFTP, from TFTP to flash. So this is what this is saying, copy from TFTP to flash. You can also do the opposite. And it's going to say, okay, what is the IP address of your TFTP server? 192.168.1.2. What's the file name? I'm just going to copy and paste. So I'm going to copy the 15.3 version, and I'm going to paste it. And what do you want to call it? Well, I want to give it the same name, so I can accept the default. I don't want to change the name. And it's starting the copy process, and voila. Okay, and now if I was to do dir, how about show flash? And now you can see I have two iOS files. I have the file that I'm currently using, and I have this brand new file that I downloaded. And I want to change the configuration to use the new file. And this is what we're going to be doing next. So, right, okay. And then from global, okay, which is where I am. And then we type boot system from global boot system flash. And then I'm going to paste the file name. That's what I would like to boot into when I boot. Okay, exit. Okay, and I can reload. And I'm gonna fast forward, and let's see what we have. Show run, and it's 15.3. Straightforward enough, everybody? It's definitely something you will be doing, just like definitely you upgrade the Windows operating system. Nobody is still running XP, hopefully. Nobody is still running Vista, hopefully. It's because every now and then we upgrade to the latest operating system, and you want to do the same thing with your routers and switches. And then if I was to do show version, and you can, this is the, here we are. So this is the version we downloaded. This is the ROM1 version, it's a different one. And we're still using the base package that is the operating system we've been using up until now. Any questions? And then of course you can delete. You no longer need that old file. So if you want, you can leave it. It's just a file. But if you're confident you're not going back, then I'd say delete it. You no longer want to leave it in your flash. And it's easy enough to do. You type delete flash and you give it the file name you want to delete, and it will delete it for you. And it's at the very bottom of that lab. Questions?
So when you update the version, what about all the security protocol? You think those are transferred over?
Yeah, well, remember, we're not changing the configuration file. It's a very good question,
okay.
Camping. So we're still using the same exact configuration file. We are upgrading the operating systems, and all operating systems are 100% backward compatible. Backward compatibility is a huge deal when it comes to the iOS operating systems. It's a huge deal for all operating systems, specifically for iOS, because you're not upgrading your configuration. You're only upgrading the operating system. And you don't want Cisco to say, well, we're no longer going to support this feature of the iOS. Well, this is going to break something somewhere. And they are very careful not to break anything. So it's backward compatible. We're just going to a newer version of the iOS.
Yeah, but throughout my career, it's always, you know, even though you upgraded to the new version of iOS, doesn't matter which OS it is, there's always they always say, yeah, it's fine, but you end up, you know, some of your application and your config file is not.
Yes, I would say this is more true for the Windows operating system than it is for the iOS operating system. So I hear what you're saying, and I agree with you. You know, you upgrade Windows to a newer version, and all of a sudden, some older application will stop working. And Microsoft tries to make it backward compatible one way or another. But for the iOS operating system, and your experience may tell you otherwise, you know, it's different, because there are lots and lots of configurations out there that haven't been changed in 5 years. And Cisco isn't going to stop a service that existed in a previous version of an iOS operating system because it will break things and they will piss off those customers, and I don't think anybody wants to do that. So this is what I know. You may find out differently on your job, but I believe, you know, they put a lot of effort into making sure they're not breaking existing capabilities. Go ahead.
It's Cody here. I just wanted to expand on that and just put my 2 cents in. When I upgraded my 1941 from 15.1 to 15.6,
yes.
I actually had to reset all my passwords, my enable, secret, all that, because I think Cisco changed the algorithm.
Okay.
For encrypting those passwords.
Okay.
I actually had to go into ROM and actually reset those passwords again. So.
All right. So
throw out there.
I can't argue with life experience, everybody. So that's an example where they broke something. But it makes sense for passwords. again, I'm not defending Cisco. I don't work for Cisco. They don't pay me any money. It makes sense for passwords because if you had an earlier encryption or hashing algorithm that isn't very secure, they're saying, look, buddy, you know, we want you to use the newer, more secure hashing encryption algorithm. So we're not really changing the configurations. You're not changing, you know, the rest of your configuration. You're just resetting your passwords to be more secure. And I didn't think they did that either. So I learned something new today. I thought even when it came to passwords, they would let you use the older mechanism unless you want yourself to use a newer, more secure hashing encryption algorithm. So I kind of understand what they did, but I didn't think they did that. So I stand corrected. Thank you, Cody. Did you have to pay for the upgrade or was it free, Cody?
No, I was just resourceful. I found some images online, I think from GNS3 or something.
Okay, yep. All right, very good. So let's do the next part of the lab. Any more questions about, and thank you, Cody, for jumping in and adding your, I'd say more than 2 cents, at least a quarter, Cody. But thank you for that.
No problem.
Okay. So the next part is to enable a security package. So just to be safe, I'm going to restart this packet tracer lab. Okay. So fast forward R1. So is this the latest version, Cody? 15.6 for a C1900?
15.7 is the official, and then 15.8 is alpha or beta or something like that.
Okay, it's being tested. Okay, very good. So show license all, show license all. So we're looking at all the licenses, and this is really a useful command, everybody. So ibase9, and it's active, it's in use. It really isn't in use. Okay, it's active, so we can enable it, and this is what we want to do. But it's giving you a little bit of information about each of these different packages. And UDI stands for Unique Device ID. And when you're purchasing a license from Cisco, you have to give them that piece of information because they want to give you a license that is going to work for you. So show license UDI. And this is my UDI. And show version, we did this before, show version. And like I said, you know, oh, crap. What happened? Oh, this is the IP base. Okay, not the security. Okay, good. Yep, so the base is enabled, but the security one isn't. And this is what we want to do. We want to enable this package, this software package for the iOS operating system. Okay. So from global config, and I'm lazy, I just typed the first 2-3 characters, license, boot, module, 1900, technology, security. So it's a long command, but that is the command. And do you want to accept? Yes, I want to accept. Okay. And I'm going to end, write, show version, and voila. And now it's available. And now if I was to type a command from this security K9, it's going to work. If I had typed it 2 minutes ago, it would have failed and said, I don't know what you're talking about. And we will be using this security package when we start talking about firewalls, because by this IP base, everybody gives you a stateless firewall. And if you want a stateful firewall, then you're going to have to use the security package. And we've done ACLs. I'm sure you all remember ACLs. And this is what we'll be talking about a week from today. And the ACLs we've done up until this point in the CCNA courses have been static, have been stateless. So these are the rules and they're static. And if it complies with them, you're fine. If not, you hit the wall. And we want to use a stateful firewall rules. And you will need the Security K9 package for that and other security features. Questions? We're good?
Zika, just one quick thing.
Yes.
For the stateful firewall, I'm a little confused about something. So on my gateway, I specified, I don't know if I'm jumping ahead too far here, but I did IP inspect and then give it the name of the profile.
Yes.
And then you can specify, TCP, UDP, anything like that. And then you go to the interface and then you apply, you say IP inspect.
Yep.
Is that the stateful firewall, or what exactly am I doing there?
Could we put this question in the parking lot till next week, Cody?
Sure.
That way, we don't confuse the rest of the class.
Okay.
But we will definitely be covering it next week,
Okay.
I hope. Okay. So that's chapter 4. So we're finishing chapter 2, so we're not very far from there. Okay, I'm going to assume you don't have any questions about upgrading to a newer version of the iOS operating system. And thank you, Camping, for saying what you said. And thank you, Cody, for adding to that. And that's something we always need to keep in mind. And this is why the very first thing people do when they want to upgrade to an operating system, it doesn't matter if it's Windows, Linux, iOS, Mac, blah, blah. You want to make sure it will continue to support your environment and your application. Nobody says, okay, Monday, we're going to upgrade all of our operating system to this newer version and see what happens. You're asking for a disaster. And this is why people, competent IT departments, take their time thoroughly testing this new operating system and testing it for security, testing it for stability, testing it for performance, and test it for backward compatibility. Will my environment continue to function in this brand new operating system? Or am I going to run into issues? And if you guys remember this, you'll be in a good shape. And if you just in a hurry to upgrade, you will probably regret that decision for one of the above reasons, either stability, security, backward compatibility, etc. So this is my advice about upgrading to a newer operating system. And then the very, very last file talks about multicast. And this is just a wiki, so we're going to go and take a look. And you all know IPv4 supports unicast, multicast, and broadcast. And you all know IPv6 doesn't support broadcast. It only supports unicast, multicast, and anycast. Anycast is unique and new to IPv6. And there is something similar to a broadcast, and it is called a multicast to all. But please, on an exam, don't say IPv6 supports a broadcast. It doesn't, but it does have a similar capability. Because anytime you want to communicate with all the devices in a local area network, you need to send the equivalent of a broadcast. In IPv6, it's a multicast to all. And here we are, and we know in IPv4, it's 2224 all the way to 239. This is the range for the multicast IPs. And I want to show you some of them. 224000. Okay, here we go. 224001. This is the all host multicast group. So anytime you want to send a multicast to all, and then 2 multicast to all routers. Just on Tuesday, we're talking about RS and RA. RS is a router. solicitation, and I said that is a multicast to all routers. This is v6 language, not v4, but it's the same thing. It's a multicast to all routers, and we do have the equivalent of that in IPv4. So I'm not gonna sit here and go over all of them, but very quickly, if you want to talk to all the OSPF routers, then we have to do a multicast to all SPF routers. If you are on RIP, then we have a different multicast for RIP. Do you guys remember VRRP? Okay, I believe we did cover it in 153. And then there is a multicast for that. And it's a long list of different multicasts for different purposes. And I don't know exactly why I put this in chapter 2, but it must have come up in a previous class, and I decided to add it to my scope. This is chapter 2. Pretty fundamental, basic stuff. Nothing fancy, just important baseline security stuff. Questions? Anything we've covered? Is this working for you? Is this format working for you? One of the things, before you answer, one of the things that I do miss about the classroom is just seeing you. Because if you guys remember from project management, from IT career skills, body language speaks volumes. So you don't have to say anything. I can just look at you and I can see if you're nodding, if the stuff is making sense, if you're rolling up your eyes, if you're snoring, if you've packed up and left, and I don't have that luxury here. So is this working for you?
I believe so.
It is for me, yeah.
Yeah, it's about 85% Zigo. I mean.
Okay. Okay. Well, if you send me an email or if you want to talk about the remaining 15% camping, please let me know.
Well, like you say, it's just the human nature of, being readily asking questions and online stuff. Yeah,
Okay.
always go
Okay.
back and look at it, but
Okay.
same thing.
Thank you. How about the rest of you? The silent majority. What do you guys think?
I think it works for me. Having the recordings does help because then I can go back through and
Okay.
watch things. That's one thing I would like. I know it's probably really hard to do because we don't have lecture capture in the actual classroom when and if we ever get back to that. But
Yes.
having the recorded things does help out a lot.
Okay. How about the labs? The labs that we do in class?
I like them. I like seeing the infrastructure there because a lot of times I go through and I try to build stuff and it doesn't usually work out when I'm trying to do something that we're practicing on. So having the labs there and being able to actually break it and then go back and not have to worry about having configured everything is always very helpful.
Okay.
Agree. The lab, you did the same thing as what you did before in class.
Yes.
You have instruction and then you're showing.
Okay, good.
Lab is fine.
And that's my expectation, that you go over these labs on your own, at your own pace, and that you do them once, twice, 3 times until they make sense. If not, go back and redo it and fill those knowledge gaps.
Yeah, I really like you doing the labs, showing it and then redo it ourselves kind of thing.
Okay.
Because I learn really well by actually seeing what to do.
Yep.
Instead of reading a bunch of text and stuff.
Yep.
But actually seeing stuff. And I got a huge TV now, so I can actually see what's going on.
Good. And thank you, Robert. And I think this is how most of us learn. I think it would be really boring if it's just slides. The very last thing I want to do is just spend 2 hours going over slides. I would be bored myself. So I try to do as little slides as possible and then move and do the labs. But I want to make sure that you understand what it is we're trying to do first before we do it. And then we can move into the lab. So let's talk about next week. So we have 11 chapters in this course. We have 9 weeks. We just finished with week 2. We covered 1.5 chapter last week. Week 1, we finished chapter 2 this week. And on Tuesday, we're talking about AAA. Does anyone remember what AAA stands for? 3 A's. You see this acronym a lot.
Accountability, authorization, and
accounting.
accountability.
Yep. So we're doing that on Tuesday, and it's not very much. This is my opinion. You may disagree with me, and I will completely respect this, but I know we can cover it. It may be 2.5 hours at most, but I believe we can cover chapter 3 on Tuesday and talk about authentication, which you're all familiar with, authorization, which you're all familiar with, and accounting, which is logging, and we've been talking a lot about that. And then on Thursday, I would like to start talking about chapter 4 and see maybe we can even finish chapter 4 on Thursday. And chapter 4 is mostly, not completely, but it's mostly a review. It's about firewalls. And we go back and we answer Cody's question about stateful and stateless firewalls. And I know you all know the difference between stateful and stateless, but we want to do it. We want to configure the router to be a stateful and stateless. And this is, I think I'm going off memory here, where we may need that security K9 package enabled. So this is my plan for next week. There's nothing scary. I'm not going to change the assignment's due date. So next week, you only have to do the labs for chapter 3. The following week, you only have to do the labs for chapter 4. But at least that way, you know, we're catching up. And I very much want to get to chapter 11 before the end of week 9. And you all know by now, week 10, Tuesday is SBA, Thursday is final exam. So we're not going to be covering any material on week 10. You think we can do it next week?
I think so.
Okay, you're going to wait. We will find out on Tuesday. I don't really think there's an awful lot to AAA. Okay, not. You're all comfortable with the concepts. I know you're all very comfortable with authenticate. I know you're all comfortable with authorize, and I know you're all comfortable with logging. So concept-wise, there's nothing new. So we're just going to go through a few labs to see how we can do each of these differently than we've done it before. And that's why my confidence is high. We can cover chapter 3 on Tuesday. I'm done for today. It's a little short. It's okay. It's a gorgeous day. I'll hit the forest with the dog. Any questions before we say goodbye?
No.
Anybody?
I just had a couple of closing thoughts.
Go ahead, Cody.
For the changing out, upgrading the images, when I copied the new image to my router, I noticed I had to do the no boot system command because I think there had previously been a number of other images. So it wouldn't load the new image until I just cleared it.
Okay.
And just specify the new image.
Okay.
And then the last thing is partially unrelated. It has to do with IPv6. When I configured IPv6 through Comcast on my router, I learned something today, this morning. You don't actually use default route, the :/0 to the WAN interface. That actually doesn't work. You have to use the on the WAN interface. You would use the IP. What is it? IPND auto config default router or default route, and that will install the route to the routing table.
Okay.
And after I did that, then I had an internet access.
Nice. So it's fully operational now with
fully
IPv4 and IPv6. That's great.
Yep.
Congrats.
I just wanted to share that.
Yep. You're one step ahead of the rest of us, Cody. So good for you. So let me ask you a question, Cody. So do you have this router behind your ISP provided router, or you got rid of that and you're using your router to connect to your ISP?
I just have my CM1000 Netgear, just a general cable modem, and then that's connected to my 1941.
Okay, cool. Very good. Very good. Thank you. Thank you. No questions? Have a great weekend, everybody, and I look forward to seeing you on Tuesday.
You too. Thanks.
Thanks.
Goodbye.
Bye.
Yeah.